Small.
And today we are doing something a little bit different. We decided to look through the AAMC's official study guide with the I guess conjunction of some other sites and some other resources that follow that study guide really well. And we want to just review all of the stuff that's actually going to be on the MCAT without stepping into too much stuff that isn't going to be on the MCAT. And the first stuff we want to go through are the behavioral sciences, Psych, Soc, and Small decided to take the lead on this one.
Yeah, I kind of thought it was the most important since it's a whole fourth of our test, and many of us science people don't take these classes in college because maybe we took AP Psych and we thought we were done with it, or, you know, it just wasn't what we were studying, so we didn't focus on it. But it's actually a fourth of our MCAT, so it's pretty important.
Yeah, especially for the score. Most people don't think about that until you take that first diagnostic or the first full-length practice test or something, and you see that your Psych Soc score sucks and it's 5-6 points below everything else. When you really start to look at these things, we've done some practice now, and we've done enough study with these definitions of words that we realized, it's actually not that hard when you just know what the actual words are that they're using.
Yeah, and some of the stuff you're learning you can actually apply to other areas, like learning about learning and memorizing and how we actually do that best. We can apply that to how we study for the MCAT.
Yeah, it's kind of like being objective about yourself and seeing yourself as the target that the Psych Soc stuff is kind of studying. I don't know. I like implementing their tools as well and the stuff that we learn from them. So, what is the first thing we are doing today?
So, to start everything, we're just going to talk about sensory processing, which is kind of important, interacting with the environment and functioning as a human. So the first thing that is on this outline would be sensation. And the biggest thing that the MCAT wants us to know about sensation is that it's just the presence of a stimulus that we may or may not pick up on. And then, sensation, we do pick up on the stimulus and sensation.
Okay.
But perception is how we interpret that sensation.
Okay, so sensation means that we actually know that the stimulus is happening, is there.
Yeah.
It's not necessarily perception, what we do to it, but it's the mechanical, if you will, signal that our body knows that the stimulus is there, whether it be through the eyes or through the skin or whatever. We have reached the next word, I believe, absolute threshold.
Yeah, absolute threshold is just that threshold to where a stimulus is high enough that it sends an electrical signal, so it gets transduced into an electrical signal that we can process in our brain. And we are bombarded constantly all day long with all sorts of sensory input, and if we processed all of it, we would not be able to function. So some of it doesn't get processed. Some of it doesn't go through conscious perception is the word for that. There's a threshold for that as well. But yeah, that's absolute threshold is just high enough for it to be transduced into an electrical signal.
So if we get, so maybe an analogy would be like sensation. If you think about an axon and transducing a signal. So let's just say you get one neurotransmitter flow to the postsynaptic neuron,
right?
And it depolarizes a little bit,
right?
But it doesn't quite go there. That is still a sensation, right? If we're translating it to the sensory processing, that would be a sensation, but not necessarily reaching the absolute threshold to move the stimulus all the way down?
No, so I think sensation has to be transduced and sent to our brains.
Okay.
But whether or not we think about it and perceive it is a little different. So I like to use the analogy, if I was getting a massage and maybe I don't have as many muscles as you would, if they were giving a really deep massage, I would perceive it as painful, whereas you would perceive it as, that's just the right amount of pressure.
Okay.
So we both feel the stimulus, but you perceive it as beneficial and I perceive it as painful.
Okay, so that's perception.
Yeah, how we think about the stimulus.
Okay, and that's not necessarily us labeling it. That could be an actual physical, it's triggering now, pain rather than it's triggering, a good sensation. Perception. It's not necessarily...
Well, perception is the labeling, but you're right.
Okay.
In order for us to feel pain, it would be triggering those nociceptors or whatever.
Gotcha.
Or maybe I say this is uncomfortable because there's no uncomfort neurons or discomfort neurons or whatever.
Right.
But yeah.
Okay, so I guess with me trying to make the connection to like an axon, then the neurotransmitters going across and opening up ion channels in the postsynaptic neuron, that would be just a stimulus.
Yeah.
So we might not actually keep the action potential going.
Right. If it
might
doesn't
stop,
ever go to the electrical transduction of like going down a neuron path.
which is a sensation.
Yes,
in this case.
it getting transduced, yes, is a
Okay.
sensation.
Very cool.
Yeah.
And the absolute threshold is kind of just like the quantity that you need to reach.
Before it goes to an electrical signal.
Gotcha.
Yeah.
Okay, very cool.
Yeah. So the next one they have on here is Weber's Law.
Always going to show up on the MCAT.
Yeah, and so he was really important in this, what is it called, psychophysics, how they figure out how our brain relates to sensation and all that.
Mm-hmm.
And he was like, I wonder what the minimum difference of these two stimuli would need to be before the person would notice it.
Okay.
And so he did all sorts of stimuli and measured the just noticeable difference between them it would take for us to realize, oh, yeah, this one feels heavier, even though there might have been a series of weights that were like if I was holding a 10-pound weight and then he handed me one that was 10.1 pounds, even though it is different, I might not be able to tell. So the formula for that is the distance between the two stimuli over the original stimuli.
Okay. So I've seen this before with like, so obviously like the weights is a really good one. Like
Yeah.
how heavy does it have to be before you notice? I've also seen in the MCAT they have like, they'll say like there's a circle on the wall and then they have a bunch of other circles or something and they see like, but the circles are getting bigger.
Yeah.
And what's the circle size at the same distance when people notice that one's actually bigger?
So circumference of the biggest one minus the next one or whatever over the first
the
one.
original. Oh, okay, so that would be your just noticeable difference.
Yeah.
Does this also apply to? I remember in physiology lab we did the
Yes, the
little
2-point threshold.
that one.
Yes, and I love that one. So that one would be like your pressure receptors, and like we did your forearm and your back and your fingertips, and they're concentrated differently in different regions of the body, like you guys did in lab.
Mm-hmm.
And so you could really tell the 2-point difference was much smaller on your fingertip, but it was really hard for you to tell on your back because we just don't have that many receptors distributed there.
Okay, yeah. All right, that's very cool. Yeah, and from the few MCAT like full length tests I've done, passages I've done, it always seems to be either like a 2-point difference, or maybe you're like it's people looking at two different things, or maybe weighing two different things in their hands. But it'll always go back to that formula, the just noticeable difference.
Yes, exactly.
Okay.
The next thing that's on this outline is one of my favorite things to read about, kind of the signal detection theory,
Yeah.
which in my head is kind of a bias for how we pick up on things around us.
Okay.
So, how perception of a stimulus is changed based on internal and external factors. So the example a lot of books give is like, if you were in a crowded room of people you didn't know, how would you respond based on if you were in a small room of people you knew, your friends, and someone called your name in both of those situations? You would kind of have a bias to answer in the smaller room.
So, actually, really funny example of that. So yesterday, I was doing some volunteering thing with another friend of mine who has my same name, which is not tall. I'm going to make all of you figure out what that really is.
I've said it.
Oh, you have? Well, then that means everyone's just going to have to go listen to all of our videos and share them with their friends.
There you go.
So they can figure out what my name is. But another friend of mine who has the same name, and apparently there was someone else at this event that had my name as well, and someone yelled out to that person, and both me and my friend turned around immediately. And they were like, 100 yards away, like down a hiking trail. And we both turned around, and I immediately thought, oh, that was signal detection. If they had yelled out some other name, I might not have turned around. But because I'm so trained to respond to my name,
Yeah.
so that's what signal detection theory is saying.
Yes. But you would probably have been even more likely to turn around if you were surrounded by like all of the people that you normally study with, or a bunch of classmates that know you and interact with you on a normal day-to-day basis.
Mm-hmm.
You would be more apt to answer in that situation.
Because I think that someone I know
Is trying to contact you.
Okay, versus if I was in a completely public place,
Right.
and they said it, then that I would be less likely, maybe still more likely than another name or something.
Right, yeah.
But I'd be less likely than if I was with people I knew.
Yeah, the cocktail party effect is kind of that it's more talking about attention, and we'll get there. We'll talk about it a little bit later, but that I can be focusing on one conversation, but if someone mentions my name in the room, I will pick up on it because I have a little bit of that signal detection, like, oh, that's my name.
Yeah.
So I think that's probably what you were talking about, kind of.
Yeah.
Yeah,
That's
so
cool,
you're
though.
totally focusing on the job you were doing, but you picked up on your name.
Yes. Yeah.
Cool. So the next one is sensory adaptation, which I think we did a couple of physiology labs on this as well.
Yeah.
But there's a physiological side to it, and then there's also a psychological side to it. One is that the psychological side is that we just stop thinking about stimuli if we don't need to. Like, I kind of forget what clothes I'm wearing or, something because I don't need to be thinking about my clothes all day long.
Would that be psychological or physiological?
Psychological, but there is a physiological side to that in that some of my touch receptors they are fast adapting, I think, so they adapt quickly to the fact that I'm wearing a shirt, and they don't keep reminding me, hey, human, you're wearing a shirt. You remember? You're wearing a shirt. It's important.
Like, I just forgot I was wearing pants until you said that.
Nobody wants
I
to
am
wear
wearing
pants.
pants.
Yeah.
So does this have anything? It immediately strikes me, or I make the connection to classical conditioning, with like, or even in The Office, if everyone remembers The Office, where Jim would, I think he would make some kind of noise and then offer Dwight like a Tic Tac, and then he would take it, and he kept doing it, and then he would just make the noise, and Dwight would, like, without even thinking, put out his hand for the Tic Tac. And so does that aspect of classical conditioning kind of have something to do with sensory adaptation, that you're not even consciously thinking about that stimulus? It might be a stretch.
I think this one is a stretch. Maybe. I think this is more due to just like our touch receptors. There's fast adapting and there's slow adapting, and they have different, like, we don't need to have constant information going to our brains that's integrated in our central nervous system that we're sitting in a chair.
Right. Okay.
So those touch receptors like fire once and then they kind of stop. But there's no conditioning that happens. I think that just that adaptation means we're getting used to whatever is happening around us. So, a good example of that would be that I use all the time is like if I'm listening to the radio and for one reason or another I have it really high up one time, I get used to it and it sounds like normal to me. But if I get in my car later and I've not been around things that are such high decibels, I'm not adapted to it. And if I get in the car and turn on my radio and it's at a high state, I go, it just kind of blows your ears out and you're like, whoa. But our ears, the hair cells, adapt to that. And so if we're at a really loud concert, we actually stop taking in so many sound waves. We just adapt to the whatever stimuli is happening. And it's almost as a protective mechanism.
And that's where the ringing comes from? I
Probably.
guess is that how we... I think I remembered hearing like that's what we perceive when we're responding to like blocking out sound.
Yeah, maybe, yeah.
But I guess my reason for bringing up that other example of like classical conditioning was I think for the MCAT, whenever they're talking about sensory adaptation, they're talking about exactly what you're saying, but they might try to trick people with a classical conditioning question. I think I've seen that before. Like classical conditioning was an answer, but the question was really asking about sensory adaptation.
Okay.
So it might just be one place where people can really make that distinction between the two, because they might try to trick you.
Yeah, and I'm coming at this like I'm an expert, which really is not true because
You're the expert here.
I've had all of one psychology class while I was in high school. So
it's more than me.
So I could be ill-equipped to answer all of the questions that you have. Maybe you're making better connections than I know, enough to answer adequately. But...
Maybe our fan base can tweet at us at the Twitter we don't have.
Oh, yeah, that'd be perfect.
Please, at Tall and Small are awesome and gonna get awesome grades on the MCAT.
That is true. Positive self-talk.
Yeah, exactly.
Navy SEALs. Okay, Psycho... Hey, leave it alone. I'll be able to do a push-up one day. Okay, psychophysics, we've already talked about. I have never heard this word before in my life, but it actually is an entire section of psychology that works on our detection and response to stimuli. So like Weber, the guy who did just noticeable difference, the people who figured out absolute threshold and signal detection theory. I don't think that's going to be very high yield at all.
Probably not, but
yeah.
It's good to know that those guys are all that's all kind of encompassed within one area of
Yeah,
psychology.
how do we perceive stimuli, if it makes it that far enough to get transduced.
Mm-hmm.
And so then some general things, how do we feel stimuli?
Yeah.
So photoreceptors, I'm just going to quiz you. You just
Okay.
define them for me. Photoreceptors.
Photoreceptors, I believe, are only found in the eye. I don't think vitamin D, that whole business, is anything like that. But photoreceptors is the crazy layering of cells in the back of the retina that cause rhodopsin to go from cis to trans conformation on like one specific part of the protein, or sorry, of the molecule. And no, rhodopsin is a protein, isn't it? I think. No, retinol. It's retinol is the individual bit that changes.
So this is where we get into a mile wide and an inch deep, right? We had to know
You're right.
all of the, on pathway, off pathway, how exactly the molecule changes for biochem and physiology, but
All
we
the
don't have to know
GPCRs.
that here.
You're
In
right.
fact, the MCAT has kind of this tendency to tell us the simple definition that we've been learning and then ask us something else about that pathway or something. So
It wants connections, not necessarily depth.
right. So know that you can go through all of that kind of in your brain, but know that there's nothing on here about the on pathway, off pathway, or how rhodopsin works specifically.
So light hits the retina,
Right.
makes vision.
Transduces an electrical signal.
Yes.
Boom, you're done.
Right.
Okay.
Okay.
We'll talk more about photoreceptors in our next video.
Mm-hmm.
Hair cells.
Hair cells.
And more specifically, where are they found primarily?
Not in your head. They're in your ear. Well, which is in your head. Not on your head. In your head.
Okay.
In the ear. In the cochlea, right?
Yes, in the
And
organ of...
Organ of Corti.
Good.
So we will also go over that in the ear video.
Third video.
But I know they're in some fluid, and based on sound waves coming in and vibrating the bones and all that stuff, it basically causes mechanical shifts in the hair cells, which then transduce out of the vestibulocochlear nerve or something, which then goes into the temporal lobes and makes you hear
after
things.
the ventral medial nucleus in the thalamus.
Right.
Yeah. But yes, and Tal said something that I love. It's so interesting that actually hair cells are the only example that at least I know of at this point in my very limited, history of biochem and physiology. But hair cells in the ear are one of the only ones that use mechanical gating. For sensory perception. So it's really, really cool. It's one of the things that makes them special.
Yeah.
Okay, so we mentioned this earlier. Ouch, something hurt. What's giving me that signal?
Nocireceptor.
There we go.
Which I don't have a really good mnemonic for remembering that, but no,
yeah.
don't hurt me. I don't know.
Or mom will tell a baby, that's a no-no, right? Like, we don't touch that, I'll give you a boo-boo. It's a no-no, nociceptor.
Okay, yeah.
Yeah.
So nociceptors, yes, they're all over the body, I think. Actually, one of the interesting things is that they're not in the body, I don't think. Not everywhere in the body. So sometimes that's, I guess, with all kinds of sensory neurons, a lot of them aren't in the body. So, like, when you have something inside you, like an endoscopy or a colonoscopy or something, I think they still put people under for that.
Right.
But I don't think they could technically feel it, because there's no need to have that on the inside of your body.
Very cool. So I know, like, stretch receptors, like, during parturition, but I guess that is kind of towards the outside of the body. So
there might be something
very
like
cool.
that, but I know they're very limited. But anyway.
Oh, but that brings up a good point. In physiology, she, talking about this, when she was talking to us about menstruation pain, I think she mentioned something like the pain receptors are so spread out in our abdomen that sometimes we can't tell where we hurt, so we just hurt all over.
Yeah, it's like radiating the pain out.
Yeah, that's very interesting. I'm glad you brought that up.
Yeah.
Okay, so I'm touching something and it's really, really hot.
Thermoreceptors.
There we go.
Thermometers, easy to remember. That
Nice.
just detects heat.
Oh, I just ate a really big ice cream and my blood has a lot of glucose in it. This is one we don't talk about normally. Tal just gave me a wonderful face of like, oh my god, I've never heard about that before.
Panic. I did not know what she was talking about. I'm going to guess
Glucose
receptors.
receptors. So in the blood, we talk about osmoregulation, right? So it's an osmoreceptor, the concentration of solute in our blood.
Oh, okay, that's where the
I didn't know we
glucose.
had receptors for that, though, which is cool.
So solute, that could mean a lot of things.
Yep.
So are there a lot of different kinds of solute receptors?
I have no idea.
But I guess if there were even, then
Probably.
their job is to do the same thing, basically, to let the body know how much stuff is in the blood. Oh,
Yep.
because you were saying osmolarity, because if you have a ton, it doesn't matter, like, I guess, what's in the blood. If you have a lot of stuff in the blood, it's going to start making it thicker.
Yep.
You might want to
Retain more water.
retain more water
Yeah.
and dilute it. Ah, cool.
These cookies that I just baked smell so good.
Olfactory.
Yeah.
Once again, not a good mnemonic for that, but yeah, that's the olfactory bulb is really cool. It's like actually almost an exposed part of your brain that's like up your nose. And when doctors like test you for the flu, I think that's what they actually go for, because the flu might like hide on that when they stick like the thing like way up your nose.
Oh,
And
wow, I've never had that happen.
yeah, they always call it tickling your brain because they technically are.
Oh, wow. So I wanted to mention one thing about olfactory receptors. What is important about the olfactory pathway that no other sensory pathway does?
It does not go through the thalamus, right?
Very good. Yeah.
And the thalamus's job is to basically input sensory information and then send it where it needs to go in the brain, right?
Yes, exactly. And so this is one of my favorite examples of structure determining function, kind of. And so it's like, we smell something and it's right on the front of our face and our nose, and then it has to go an extremely small distance comparatively to anything else.
Yeah.
To go to where it needs to go. So the olfactory bulbs are right on the bottom of our brain. So it's so close that it doesn't need to be routed through the thalamus.
That's really cool.
Yeah.
Yeah. Dang. And I guess we would have developed the sense of smell probably after we developed a thalamus. So I don't know. I'd like to see the the evolution behind sensation, and like how did the thalamus come to play an important role. And like, was smell first? It might be. You probably think back to like fish and like early invertebrate animals.
Fine dining and breathing, my love.
Fine dining and breathing. I'm so glad that's becoming a thing. What's next?
Okay, so I did want to mention, I think I said it was the only sensory pathway that happens that way. And so I don't know why the temporal lobe, our hearing goes into the thalamus, into the ventral mediate nucleus in the thalamus, and then goes back to the temporal lobe.
Right.
And those are right next to each other. So maybe structure determining function being the reason that the olfactory bulbs are right there and it doesn't go through the thalamus. Maybe that's not the right reasoning. I didn't read that anywhere. But
Ooh, maybe it's because ears are earlier? Well, no. Or later developments? I don't know. I'm trying to find dining and breathing. What else?
Yep, fine. Okay.
So you were talking about another type of quiz me.
Yeah. So I just baked all of the cookies, and now I'm going to eat the cookies.
Because they smell so good.
Yeah.
So I'm going to put them on my tongue where my
Don't mess it
gustatory
Okay.
sensation is.
And what are the little bumps on your tongue that people see and misname all the time?
The ones that people see, they call them taste buds.
Ugh.
No, they call them taste buds.
Right, they do call them.
They're not.
Right, what are they?
Are they lingual papillae?
Yep, they are. And so you have fungiform and something else. There's all different, there's a big mushroomy ones and there's all the little ones. But on a cross section of one of the lingual papillae, you can actually see embedded taste buds, and they look like little flower buds. They're really cool. But yeah, we can't see taste buds, so that's a really common misconception. That's also kind of annoying. But that sensory pathway gets started with the chemical structure of whatever you're eating. And that makes it the same as the olfactory receptors that also take up I don't know what the number is, but like 1 billion different receptors.
Yeah.
Our olfactory receptors are extremely accurate. And olfaction is also tied to our limbic system, our emotions. So that's why you can smell something and immediately, like if I was smelling cookies, I could immediately get taken back to my nanny's house when I was like 5 eating cookies with her.
Yeah.
It's so cool. But those two are your big chemical receptors. And then sensory pathways, we kind of talked about some of them, and we'll get into more detail for the others in separate videos. but kind of just how does that stimulus come into our body, get transduced if it reaches the absolute threshold, and then get perceived and processed in our noggins.
Yeah. So how do all of these different pathways, I think, especially like I know they always ask a lot of questions about the eyes, a lot of questions about the ears, and sometimes they'll say, you know, they have, let's just say that like a surgeon snips something that's like, you know, in this part of the pathway, or like they lack this part of the pathway. What would they see, or what would they hear, what would they, you know, and those are the kind of questions you're going to get in the MCAT. So it's really important to know this basic stuff so you can recognize where the question's asking you, but then obviously the sensory pathways are going to be, you know, the majority of the real science that's going on, I guess.
We're going to be talking about a couple of themes throughout these videos for psych and biochem, and as many as we get to make before our test day. But one of them is be able to read, you know, a couple of terms or one term and jump into like a 5 to 10 minute lecture about it to yourself.
Yeah.
And so that's why I like doing in the car. Like, in order to rehearse the eye enough to learn it, I had to teach it to myself in the car 3 or 4 times.
Yeah.
So.
And I've heard people say before, if you get the quick sheets from Kaplan, a lot of people use those for notes. If you get the quick sheets from Kaplan, or, you know, any other equivalent thing, you put them all up on like a dartboard, and you throw a dart at the dartboard. You should be able to land on any of those topics and be able to talk for 5 minutes or so about, or just, you know, say all the basics about that topic. And if you can do that, you've got all the content you need for the MCAT.
Very good point.
Yeah, strong work, Small.